our lesson for today, we will try to explain Chapter 3, Lesson 3, Part B, Higher Order Derivative for Grade 12 Scientific. And be careful, there is a link for the exercise of this lesson down below in description. Download it and use it carefully. Let us start our lesson. I am Tawfiq Omar Uthman, math teacher. Higher order derivative. We write the sample of the first derivative as y prime or f prime of x or dy over dx and dfx over dx. And the second derivative is y double prime and f double prime of x and d square y dx square, d square f of x and dx square. And we continue like this. Here in the fourth derivative, we write y and write 4 between two brackets to make a difference between derivative and the power. And nth derivative is y. Example number 1. Find the third derivative of the function f of x is equal x sine x. As you can see that the f of x is the product of two functions, x and sine x. To take a first derivative, we need to use the product rules, which says the first one time the derivative of the second one, the derivative of sine is cosine, plus the second one sine x time derivative of the first one, which is 1. And now to take a second derivative is equal the first one time the derivative of the cosine, which is minus sine, plus the second one cosine x time the derivative of the first one, which is x, is 1. And then plus the derivative of sine x, which is cosine x. Simplifying, it become the second derivative is equal minus x sine x cosine x plus cosine x is 2 cosine x. And the third derivative is the first one, which is minus x times the derivative of the second one, sine x, is cosine, plus the second one, sine x, times the derivative of the first one, the derivative of minus x is minus 1, plus 2, and the derivative of cosine is minus sine. Simplifying, here minus x cosine x, minus 1 time plus sine is minus sine, 2 time minus sine x is minus 2 sine x, and the third derivative is equal minus x cosine x minus sine x minus 2 sine x is minus 3 sine x. Check it out. Find the third derivative of the function f of x is equal x cosine x. F of x is the product of two functions. Use the rule of product. If the first derivative is equal, the first one x times the derivative of cosine is minus sine, plus the second one cosine x times the derivative of the first one, which is 1, and f prime of x is equal minus x sine x plus cosine x. And now take the second derivative f double prime of x is equal, the first one minus x times the derivative of sine is cosine plus the second one sine x times the derivative of the first one, which is minus x is minus 1. The derivative of cosine is minus sine. Simplifying, the second derivative is equal minus x cosine x minus 2 sine x. And now take the third derivative. The third derivative is equal. The first one is minus x times the derivative of cosine is minus sine x plus the second one, which is cosine x, times the derivative of the first one. The derivative of minus x is minus 1 minus 2. The derivative of sine x is cosine x. Simplifying, the third derivative is equal x sine x minus time minus is plus minus cosine minus 2 cosine is minus 3 cosine x. Indeterminate form in the limit of a function. In evaluating limits, you face some cases of limit in the form 0 over 0 or infinity over infinity, which called indeterminate form. To remove the indetermination using the derivative, follow this theory. Theorem 3.8, Hopital rule. F and g are two differentiable functions and g prime of x not equal 0 in the neighborhood of c. If limit x approach to c, fx over gx is undetermined form, 0 over 0 or infinity over infinity, then limit x approach to c, fx over gx is equal limit of x approach to c for the derivative of fx over the derivative of gx. We can repeat this rule for more than one time. Example number 5. Find the limit x approach to 0, x over x minus square root of x. Here we use two ways for find this limit. The first one by multiplying by conjugate of the denominator, which is x minus square root of x, make it x plus square root of x, multiply the numerator and the denominator. It becomes limit when x approach to the 0, x plus square root of x. Here x times x is x square minus time plus is minus square root of x times square root of x is x. Factoring x square minus x by taking a common factor x, it becomes limit when x approach to 0 for x plus square root of x times x minus 1. Cancelling x with x, it remains limit when x approach to 0 for x plus square root of x over x minus 1. And replacing 0 in place of x, it becomes 0 plus square root of 0 over 0 minus 1, which is equal to 0. And now we are trying to solve this limit by using Hopital rule. Limit when x approach to 0 for x over x minus square root of x. To use the Hopital way, we must take the derivative of the numerator and denominator. Then limit when x approach to 0, the derivative of x over the derivative of x minus square root of x, which equal the derivative of x is 1 and the derivative of x is 1 minus the derivative of square root of x is 1 over 2 x squared. Simplifying, it become limit when x approach to 0 for 2 square root of x over 2 square root of x minus 1. Replacing 0, it become 0. As you can see, is the same answer. Check it out. Find limit when x approach to minus 1 for 2x squared minus 2 over x plus 1. By factoring, taking 2 as a common factor and then factoring this by using the difference between two squares, it become limit when x approach to minus 1, 2x minus 1, x plus 1 over x plus 1. Cancelling x plus 1 with x plus 1, it remain limit when x approach to minus 1 for 2x minus 1. Replacing minus 1, 2 minus 2, 1 is equal minus 4. Using Hopital, limit when x approach to minus 1, taking a derivative for numerator and denominator, it become the derivative of numerator is 2 times 2 is 4x, and the derivative of minus 2 is 0, and the derivative of x is 1, and the derivative of 1 is 0. It remains 4x over 1. Replacing minus 1, it becomes 4 times minus 1 is minus 4, which is the same answer. Example number 6. Find limit when x approach to 0 for sine x over x. Taking the derivative of the denominator and numerator is become the derivative of sine is cosine and the derivative of x is 1. Then replace 0, it become cosine 0. Cosine 0 is 1. And here, take the derivative of denominator and numerator. It become the derivative of numerator. The derivative of 1 is 0 minus the derivative of cosine is minus sine. Minus time minus is plus sine x over 1. The derivative of x is 1. Replacing 0, it becomes sine of 0, which is 0. Find limit when x approach to positive infinity, ln x over x. Limit when x approach to the positive infinity, ln x over x. Ln x approach to the positive infinity and x approach to the positive infinity. As you can see in here in the graph of the function. If we draw the graph of ln, it is like this. As you can see, when x goes to the positive infinity, fx goes to the positive infinity. And if we draw the graph of x, which is like this, as you can see, when x goes to the positive infinity, fx goes to the positive infinity. Therefore, limit when x approach for positive infinity, ln x over x is positive infinity over positive infinity, which is indeterminate form. Therefore, we must take the derivative of the numerator and denominator. Limit when x approach to the positive infinity, derivative of ln x over derivative of x, which is the derivative of ln x is 1 over x and the derivative of x is 1. And now, as we know that when x approach to the positive infinity, 1 over x goes to, or approach to the 0. As you can see, the function ln x over x, when x goes to the positive infinity, the function approach to the 0. check it out 7. Find limit when x approach to the positive infinity, x over e to the power x. Limit when x approach to the positive infinity, x over e to the power x. As you can see here in the graph of these functions, the graph of e when x goes to the positive infinity, e of x goes to the positive infinity, and when x goes to the positive infinity, x goes to the positive infinity. Therefore, limit when x approach to the positive infinity, x over e to the power x is positive infinity over positive infinity, which is indeterminate form. And now we must take the derivative of the numerator and denominator. The derivative of numerator is 1 and the derivative of the denominator is the derivative of e to the power x is e to the power x, and here this function goes to the 0. As you can see here that the function f of x equal to x over e to the power x. When x goes to the positive infinity, this function approach to the 0. Example number 8. Find limit when x approach to the minus infinity for x squared over e to the power minus x. Limit when x approach to the minus infinity, x squared over e to the power minus x. As you can see here in the graph of these two functions, as you can see the graph of e to the power minus x is like this. When x goes to the negative infinity for the left side, the function goes to the positive infinity, And when x goes to the negative infinity, x squared goes to the positive infinity too. That means this is positive infinity over positive infinity. It is undetermined form, therefore we must take the derivative of the numerator and denominator. The derivative of x squared is equal 2x, and the derivative of e to the power minus x is minus e to the power minus x. And now, if we draw these two graphs, again, you can see when we draw the graph of minus e minus to the power minus x is like this. As you can see, when x goes to the negative infinity, the graph goes to the negative infinity. When x goes to the negative infinity, the 2x goes to the negative infinity too. That means limit when x approach to the minus infinity for 2x over minus e to the power minus x is minus infinity over minus infinity, which is indeterminate form too. Therefore, we must take another time the derivative of numerator and denominator. The limit when x approach to the minus infinity, the derivative of 2x over the derivative of minus e to the power minus x. The derivative of 2x is 2, and the derivative of minus e minus x is e to the minus x. As you can see, the limit when x approach to the minus infinity for 2 over e to the power minus x, 2 is constant, and here is a variable, therefore 0. As you can see here, when x approach to the negative infinity, the x squared over e to the power x minus x goes to 0. Example number 8. Find limit when x approach to the positive infinity, e to the power x over x squared. Limit when x approach to the positive infinity, e to the power x over x squared. As drawn here, you can see when x goes to the positive infinity, both of them goes to the positive infinity. Therefore, it is positive infinity over positive infinity. That means it's indeterminate form. We must take the derivative. The derivative of e to the power x is e to the power x, and the derivative of x squared is 2x. As we drawn here, as you can see, when x approach to the positive infinity, both of them, e to the power x and 2x goes to the positive infinity. Therefore, it is positive infinity over positive infinity. It is indeterminate form again. Therefore, we must take another time the derivative of numerator and denominator. The derivative of e to the power x is e to the power x, and the derivative of 2x is 2. When x approaches to the positive infinity, e to the power x over 2 goes to the positive infinity, as you can see here in the graph of this function. Here we reach the end of the lesson. Please subscribe the page and share it with your friends so that everyone benefit and get each new video. Write your comment and press your like button, and thank you for watching. Do not forget there is a link for the exercise of this lesson down below in the description. Download it and use it carefully. Thank you for watching, and goodbye.